Good morning, ladies and gentlemen. There's just a few people wandering in from the last session, but we might get going. We do have our speaker online. This is going to be an online presentation. So welcome to the modern world. My name's John Turnidge. I'm chairing the session, and it is indeed a pleasure to introduce Ramanan Laxminarayan, who actually did present at our last conference, but is definitely a global leader. You can read his long CV in your app, but he is a person who's driving everybody in the world to think more clearly about antimicrobial resistance and how it should be managed, particularly in the One Health context, a passion also of mine. So without further ado, I will hand over to Ramanan, and thank you very much. We'll hopefully enjoy your talk.
Thanks, John. Thanks for that very kind introduction. And I am sorry to not be there in person. I hope you can see my slides. So, so this is really, about, I guess, the topic that seems to come to mind the most when one thinks about One Health and infectious diseases, apart from emerging zoonoses, which is AMR control. And I think there's no other real way to think about AMR control except under a One Health umbrella. And, that might be, that might seem a bit far-fetched, but I think that considering how things are going, this is going to get more and more important in how we frame this issue. Now, AMR, as we know, is going from bad to worse, and the COVID pandemic has done AMR no favors at all. Resistance has jumped up about 10% in India. It has gone up significantly in the United States. And generally, we don't see declines in AMR over time, very rarely. And on the left, you see the drug resistance index, which is a weighted average of resistance, weighted by how frequently you use an antibiotic, which is a metric that we calculate at the One Health Trust, previously known as CDDEP. And it basically tells you how bad things are in a single metric. India and Turkey are at one end of the scale, and Sweden and Germany are at the other end of the scale, with most countries being somewhere in between. And developing countries, low and middle income countries, in particularly struggle with drug resistance for two reasons. One is, of course, there's a high background burden of infectious disease. But the second is that once the first line drugs fail, there's very little access to advanced antibiotics, both because of registration of those drugs, which doesn't necessarily happen in those countries, but also because of the price. And for both these reasons, it is absolutely imperative that we try to keep first-line antibiotics going for as long as possible in many LMICs, because the alternatives are not that great. Now, the concept of One Health is really, really old, and we've got, the original quote comes from Chief Sealt, who, says, "We do not weave the web of life. We are merely whatever we do to this web." The whole idea is that we're merely a strand in this web of life, and whatever we do to this web, we do to ourselves. And I think that's really happening with AMR as well. We think of it as primarily around antimicrobial resistance and infectious disease, but increasingly we're understanding that it's really around wildlife and other diseases as well. So it's also about non-communicable disease, which is something which we think of in a slightly separate way than drug resistance and infectious disease, but that's not really the case. I think COVID has taught us that people who are most at risk for many communicable diseases also are those with hypertension, diabetes. And so these are not as separate as we might have previously thought. Now, the background context is we have a growing global population. We just hit 8 billion a few weeks ago, and we're about to hit about 9.5 billion people before the world population starts, leveling off and then dropping. And that generally means a lot more mouths to feed. Humans now account for more than a third of the biomass of all mammals on this planet. And the remaining, most of the remainder, 60%, is made up of domesticated livestock, mostly cows and pigs. Wild mammals only account for about 4% of the mammalian biomass on the planet.
And even if you take birds, the biomass of poultry is about 3 times higher than that of wild birds, all of which suggests that humans and what we eat in terms of animal protein makes up much of the planet, which means that anything we do in how we raise that animal protein has profound impacts on the environment, on animal health, and on human health. We've seen resistance emerge and spread very quickly around the world. Now, this is New Delhi metallobated lactase, first detected in the Swedish patient actually Indian patient in Sweden, quickly spread around the world. And we've seen much more recently MCR1 and plasmid-mediated cholesterol resistance, which probably emerged, in pigs and then has spread to animals, but it doesn't go just in one direction. It goes back and forth between animals and pigs, and has now been found in animals, humans, or the environment, or some combination thereof in nearly every country around the world that has looked for it. Now, we probably have some ideas about the origins of cholesterol resistance. The earliest isolates go back to 1970s, there's an indication that trade in food animals and meat and the movement to colonize humans, both of these could have played a role in rapid dissemination. And again, I'd like to remind you that animals move around a lot. The average pig in the world travels internationally far more than the average human. And so it's no surprise that animals are carrying these pathogens around the world. Now, the FAO puts out this global distribution of cattle, pigs, chickens, and ducks. That's A, B, C, and D on your screen. So cattle, as you can see, India has more cattle than, the China, the EU, and Europe, and the United States all put together. Very important source of livelihoods. Pigs, of course, concentrated largely in Europe, China, and parts of the United States. And poultry now increasing worldwide. The growing appetite for animal protein is everywhere, and anyone who can afford it and would normally eat meat, once a year or twice a year, now really wants to eat it every day of the year. Now, the story of how antibiotics got into animals is an interesting one. It started with this woman on the left, Cecile Steele, and this is the house where she used to raise her chicks. She tried to order 10 chicks once, and she ended up getting a flock of 500 by accident. She just wanted to have some backyard chicks. And then she raised all of them, and she found that she could make a lot of money of doing this. And this is her house, which is now a heritage site on the eastern shore of Maryland. And as a consequence, the modern factory farming industry, the broiler industry, was born in that part of the United States, Delaware, Maryland, and Virginia. Of course, the World War II boosted broiler production in the United States, but all the poultry produced was to be sent to the armed forces. And red meat was rationed, but poultry was not. So people who would normally eat chicken only, once a week at most, started to eat it far more frequently because it was being available. It wasn't just a Sunday dinner thing. It also was an efficient way to raise meat because broiler chickens, the feed conversion ratio is much greater than it is even for eggs or beef or for pork. So it means that the amount of meat that you get per unit of feed is much greater. Now, this man was the one who did the early experiments on showing that Streptomyces orophaciens, could be could be helpful in So and showed that this could increase the productivity of poultry. And ever since, antibiotics have been a common part of the food production system. So this was the cover, the wonder drug automycin found to spur growth 50%, which was on the cover of the New York Times, and Thomas Jukes, who was also involved in those experiments. Now, how antibiotics are useful for growth promotion is not fully understood, but we understand a great deal of it, which is that if you have increasing genetic potential of poultry or indeed of pigs as well, that if you have an absence of either nutrition, of herd health, or of hygiene, that antibiotics can make up for some of these. So if you have none of these, the antibiotics, which is the the efficiency improvement on the top line compared to the baseline, is not that great. If you have all of these, herd health, nutrition, and hygiene, and of course a good veterinarian, then you don't need the antibiotics either. It's only when you have some of these, but you don't have the others, that the antibiotics play the greatest role, and that's what you see in this picture. So the current protein demand in the world is about 202 million tons, and meat production has plateaued in high-income countries, but it's growing rapidly in the rest of the world, and 2/3 of the tonnage of antibiotics is used in agriculture and aquaculture. And but at the same time, the feed practices, the veterinary practices have improved to the point where the percentage improvement in average daily growth, which was 8 to 10% in the 1950s and 60s, has come down for the reason that I mentioned earlier. If you have good hygiene and animal health, you really don't need the antibiotics, and that's what you're seeing now, which is the antibiotics are becoming more and more optional, and it will only take a small nudge to push them over the edge and not have them be used at all. Now, the demand for poultry in India and China is set to increase about 2 to 7-fold between 2000 and 2030. India, of course, starts from a low base and goes up much higher, and the top increases because of the increase in population. The combination in per capita consumption and the overall population is resulting in an overall increase in consumption. Meanwhile, pig production has already increased significantly in China. Per capita pork consumption has gone up 6-fold, and the number of pigs produced has also gone up a similar amount between 1975 and 2014, to the point where today pigs in China, there are more pigs in China, far more in fact than in the United States. In fact, the largest US producer of pigs is owned by a Chinese company. And pigs in China are the single largest consumers of antibiotics in the world. China consumes half the world's antibiotics, mostly in animals, and of those, the pigs get most of those. In fact, when we published this paper, this particular figure was considered redundant by the editors, because they said, well, you can clearly see that China consumes more antibiotics than the rest of the world in the animal production industry. There's no point showing a figure. You can just say that one sentence. But it's really stark when you put it in a figure to show how much more China consumes than the rest of the world. And 2013, the global consumption of all antimicrobials was 131,000 tons, and it's projected to reach about 200,000 tons by 2030. Now, all of this has consequences also for resistance, both in animals as well as in humans. In animals, resistance has increased nearly 3-fold between 2000 and 2018. And you could see that in both chickens and pigs. You really don't see much of that effect in cattle. But it shows that it's not just a human problem. If we don't take care of resistance, we will have serious problems with raising the kind of animal protein that the world is demanding. Whether or not that's reasonable or something to be encouraged is a completely different question. But given the current demand, it's going to be hard to do that if you have the levels of resistance that you see today. Now, you can actually reduce that, because in fact, we did this work for the OECD to look at what it would cost to reduce antibiotic growth promoters, and it obviously increases workload. There's great excess mortality, there's more excess feeding days, and also increased medication. But the total cost per pig is only $1.34. So then one has to ask the question, is it worth saving the antibiotic for humans to not be using them for growth promotion if the additional cost is only $1.34? Now, someone in the pork industry will come back and say, well, $1.34, this is US dollars 34, seems like a small amount, but that industry works on very small margins. So this could be an important differentiator. But this is where the entire world, if everybody took antibiotics out of growth promotion, then it levels the playing field. And it means that it is not in the interest of any single country or manufacturer to try to use antibiotics for growth promotion. And I think this is not a question of whether we should do it. It's a question of when. And I think growth promotion is just not sustainable given the huge toll that we're seeing on resistance. And I think we continue to ignore AMR at our peril. I don't need to tell this audience that, but I think for the rest of the world, they are not we're not really getting the seriousness of attention that this topic really deserves. So this was the potential loss in annual meat production following the growth promoter withdrawal in percentage terms. As you can see, Australia might have a little bit more, and some countries have more, but some countries actually, lose very little. Now, global antibiotic use in food animals can be reduced in a baseline with no reduction. That's about 200,000 tons more, like I mentioned earlier. Sorry, 200,000 tons, total consumption. But if you were to either cap the amount of antibiotics used per animal product, which is something the OECD already does or is considering, and China is also considering, have a meat reduction, which means that just like people drive less, maybe consume less meat. This is not as crazy as it seems. In fact, the Chinese government is encouraging its population to consume less meat because of the huge environmental consequences of raising the kind of meat that the population consumes. So this is not to say everyone needs to be vegetarian, but certainly it could mean that paying attention to the environmental consequences of meat and what it takes to produce that meat is probably not such a crazy idea. You can think of a tax on antibiotics, or you can think of a meat reduction and a tax on antibiotics, or a combination of all of these, which might get you to this bottommost figure, which is a 40,000 ton volume by 2030, which I think is far more palatable than the 200,000 tons. Now, we haven't talked about aquaculture, another important area in which antibiotics are used. Again, huge increases projected there. Again, most of that happening in China, but also in India and also Indonesia and Vietnam. Now, antibiotics which we use in human medicine are exactly the same as the ones that are being used for bacterial infections in a whole range of fish, salmon, catfish, trout, and very common fish infections are the same as what you see in humans, diarrhea, sepsis, but they also have skin ulcers, all of which are treated that way. And they help prevent infections, especially when clean water supplies are limited. And increasingly, clean water supplies for aquaculture are very limited. And they're used in the same way as for terrestrial animals, metaphylaxis and treatment. And the US FDA has approved certain drugs for the Food and Drug Administration has approved certain drugs as long as there's less than a mandated maximum residue limit. Now, but how are resistant bacteria transmitted to humans? So they can either come through handling, people are handled store-bought tilapia, for instance, and this has been shown in various parts of the world. They could also be through cross-contamination and foodborne infections. So Vibrio parahemolyticus is a common foodborne disease in Japan, and these have been linked to consumption of aquaculture tinned fish, and also in just the retail market through food preparation at home or handling in the market. Now, antibiotic use in aquaculture is estimated at about 10,000 tons, much less than for terrestrial animals. And from baseline, it's set to go up to about 13,000 tons. So overall, not a large amount right now, but given the increase in aquaculture, this could end up also becoming an important sync antibiotics and by extension for resistance. And the APEC region accounts for the overwhelming majority of the global consumption. So right around where you folks are right now, but starting all the way from India all the way into all the way through to the western coast of the United States. And this is all of these stacked up together. So the fish at the very top, then the pigs, then the chickens, cattle, and then the humans. Humans and pigs obviously are the most important, a single species, but the others contribute as well. But it's obviously a mistake to think that all of these are just coming to human populations. Humans also transmit resistant pathogens into the environment. We transmit to pigs, we transmit to fish. And so because we all live in this common pool of bacteria, I think it's hard to really, place blame anywhere. And it's kind of pointless to do that. I think we really need to sort of dial down antibiotic consumption when it is not needed globally, because this is a major risk factor for resistance. Now, there are many scenarios in which producers use antibiotics when animals display abnormal symptoms of behavior, when they're falling ill, they don't grow as much, where there's about a change or the neighbors, something's happening on the neighbors' farms. And interestingly, not a big difference between chicken, pig, and aquaculture producers in terms of how they think about when to use the antibiotic. Now, turning to the environment, we do have antibiotic concentrations in select aquatic environments. This is a very nice paper by Joachim Larsen and Carl Frederick Flack in Nature Reviews. And out of the ocean seas, yes, there are antibiotics, but the concentrations are extremely low, just because there's dilution effects, right? So you can throw a tub of antibiotics into the Pacific, and that's going to have much less of an effect than if you threw it into your neighboring lake. And so the industrially polluted surface waters are really the places of concern, untreated hospital effluent, and to a lesser extent, untreated municipal sewage. So clearly there's a gradation here, and you achieve minimum inhibitory concentrations only in the effluent, particularly in hospital effluents and also in industrially polluted surface water. So the goal is not to try to prevent resistant pathogens from being in every location. I think there are many places where there may be reservoirs or they may be out there, but they really don't pose a risk. So the hazard may be there, but the risk is non-existent or very, very small. The risk tends to be concentrated when you have high concentrations, particularly in effluent from pharmaceutical plants. And we can focus, of course, on one of two things, which is transmission of the pathogenic bacteria between humans, animals, and the environment, or we can look at uptake of new resistance factors. And it's not necessarily an either or, but we do need to think about what we're doing when we look at surveillance. And it's far more common. This transmission, the risks are in principle quantifiable and predictable. You can look at the consequence of every transmission event, and you can reduce transmission rates. Now, those are all the reasons to focus on the transmission aspect. Now, if you look at uptake of new resistance factors from diverse microbiota, that's much harder to predict. And, single transfer events, consequences may be fast, but may also be completely non-existent because, that particular transfer event really doesn't go anywhere in an evolutionary sense. So I think we tend to focus on the emergence of resistance, but we fail to give enough attention to the transmission of resistant pathogens. And my own feeling is that we really should pay a lot more attention to transmission. And we should do that in humans through better water and sanitation, through vaccination, through better infection control. But we also need to pay attention to how pathogenic bacteria are moving between humans, animals, and the environment, and try to minimize that transmission. And the uptake is important, but it's going to be a slightly more, I don't think we have a grip on it. I don't think we have effective tools to be able to prevent this in a clear way. Of course, antibiotics that go through humans, go through animals, where do they all end up? In the poop. And all of that goes into the river systems. In China, for instance, it's about 54,000 tons of antibiotics that are excreted by animals and humans. Most of it goes into the receiving environment, into the 58 river basins in China. And this is not just China. This is going to be in any country when antibiotics are being used at scale. You also see resistance genes in Chinese swine farms, every kind that you can think of. Very good work by Yongwan Zhu and Jim Teacher and others, showing that nearly every form of resistance, whether it's antibody deactivation, efflux pump, cellular protection, all are to be found in bacteria that are found in farm samples, and resistance to every class of antibiotics that we can think of. So resistance is out there, but the question again to think about is how important is it from the perspective of actually causing disease in animals or humans? And this is where we really need to pay attention. Now, monitoring resistance in the environment can be quite helpful because it can also be a proxy for what you might be seeing in humans. So this is a very nice study that was published out of Europe in Eurosurveillance. Sorry, I'm missing a reference here, but this is this is a paper in Eurosurveillance from 2019, showing a very nice correlation between hospital sewage mean resistance rates and what you find in patients, either in urine or in blood. And this correlation probably means that for surveillance, we don't necessarily only have to look at surveillance passive surveillance in the hospitalized population, we could be using sewage samples to try to understand what's going on in the hospital. Now, switching gears, I think we need to think about climate change, which is this big looming sort of threat, which is going to affect everything, but particularly when it comes to bacterial pathogens as well. And in work that we have done, that others have done, you see gram-negative bloodstream infections being associated with higher temperatures quite significantly. So these are the adjusted percentage changes in and bloodstream infection frequency for every 10 degree Fahrenheit increase in monthly temperature. And so you can look at association across all seasons. That's about a 10% increase in Acinetobacter, 3.5% increase in E. coli, Klebsiella, Pseudomonas, much more so for the gram-negatives than for the gram-positives, for every 5.6 degree increase in monthly temperature. And you do see those variations across the seasons as well. The summers do tend to have more of the change. So antibiotic resistance does increase with minimum temperature. This is a nice study done by McFadden and others in Nature Climate Change. And as the minimum temperature increases, normalized resistance has been going up, and it's actually getting steeper over time. So it's 2015. And this is regardless of the antibiotic oral or IV, but fairly strong correlations that I don't think we have good explanations for yet, but certainly something that's being observed more and more. So, we in a One Health sense, we really need to understand how climate change is going to have a resistance profile and get ahead of the curve to anticipate it rather than wait for these changes and then try to figure out how to respond to it. Now, we haven't talked about fungal pathogens, which actually, to be honest, worry me much more than even the bacterial ones, simply because our number of modalities for treating fungal pathogens are far more limited. Azoles, the common category of antifungals, is used widely in plants and in animals as well as in humans. And some nice work showing that global warming does increase ambient temperatures, which selects fungal clades, which can be reproduced in avian and mammalian basal temperatures. So the hypothesis is that the reason why we don't have as many fungal infections as one might expect is because our basal body temperature is simply too high for the fungi to survive. But if they are being selected for thermotolerance and other forms of tolerance that help them survive in the intermediate steps as into humans, these thermotolerant strains, like for Candida auris, they get moved through wildbird populations into farming activities and into humans. And of course, these are all hypotheses where you're seeing correlations, but sometimes you're seeing some causation as well when you look at the phylogenetics. And you're seeing that there is this very systematic selection for particular kinds of traits which would make the fungi more likely to survive in humans. And this is something to really watch out for as well. Now, the environment is not just out there. There are times when we interact with the environment in significant ways. So we have in India mass bathing events when, during particular times of the year, people go in and bathe in the river at the same time. And NDM1 is found to be 20 times more greater in the Ganges during the pilgrimage season than at other times of the year. These are methods, of course, of transmission, which can allow many people coming from different parts of this country, or indeed in other sort of events from different parts of the world, to carry resistance back to where they came from. This was a nice study that showed that, in these two places, Rishikesh, Haridwar, where you do have mass bathing events, the red is during the bathing event and the blue is when there is not. There is an increase, whereas in Delhi, where there is no mass bathing event, you really don't see that differentiation between seasons. Now, sorry. So where are we going with all of this? I think there's obviously a need for us to really sort of, hunker down and look at more sort of systematic thought processes about how we're going to leverage this One Health framework to think about how to prevent resistance. Because much of the time we're doing this just in, say, a human health framework, where we're not paying attention to all the ways in which resistance is coming in, and without understanding it, we might be, missing the big part of the picture. We also may be missing a big part of the picture when it comes to new resistance genes and where they may be coming from. Of course, the general sort of theory of zoonoses is of pathogens that start in wild animals, they spill over into domestic animals, and then there's the domestic animal amplification, and then it comes into humans. Now, for bacterial pathogens and for resistance, it may not necessarily just be going in this one direction, maybe going in the exact opposite direction as well. But spillovers are ubiquitous, and in fact, I think the idea of a spillover is not really meaningful when it comes to AMR, just because we're all like fish living in the same bacterial ocean that all other animals and crops in the environment are all part of the same ocean. And so there's no spillover. It's just that we all live in that same environment, and we need to constantly be looking where resistant pathogens are moving. So these ideas of forecast readiness and early detection, I think we need to be doing across the One Health domain at all times in order to be prepared for what might emerge in humans and certainly affect animals as well. Now, in the case of humans, we do have these in-depth network surveillance sites which do look at what's happening in human populations at scale. About 3.8 million people are under surveillance when I say under surveillance, in the sense that of public health surveillance sites in many parts of the world, especially in low and middle income countries. There are 52 of these across 20 countries in the world. But they all focus just on humans. Now, of course, they're not doing it just for AMR or for infectious diseases. But even so, I think this way of looking at just human populations is probably no longer relevant in a world where we now understand better, like we did in the past. I mean, this idea of One Health is, like I said, it's a very old idea. It's there in nearly every sort of civilization. This idea of interconnectedness is very core. It certainly is in India. It was true in amongst Native American populations. So this is not new, but we're rediscovering what was always around. And we need to also converge our thinking on surveillance to make sure that these are surveillance sites that work in a One Health way. We're trying to do that in a field station called the My Valley, where we're looking at a catchment area covering agriculture, forest, and urban land. Catchment area of human population is about 60,000. We're surveying domestic animals and wildlife populations. And the longitudinal data, along with markers of human, animal, and environmental health, is what we hope will help us understand, how this One Health domain is interacting, and give us a little more by way of insight about One Health interventions as well. How can we, minimize the risk? It's impossible to minimize the hazard. We're always going to have resistant bacteria somewhere, but how can we minimize the risk, particularly when consequences for human health or for animal health are pretty significant? That's actually our field station out there. This is north of Bangalore in India, and this is our study center, which is coming up around there. So I think for many colleagues who've known my work through the Center for Disease Dynamics, Economics, and Policy, CDDEP, in recognition, I guess, of the idea that we need to sort of move to an idea of thinking about One Health as being our framing for all of the work that we do. We were renamed the One Health Trust a few years, actually 2 years ago. And this is our new website, and I really appreciate the opportunity to be there. I'm, again, deeply apologetic that I'm not there in person. I would love to be on that side of the Indian Ocean rather than on this side, which is where I am. And I hope to join you in person next time in Istanbul, I believe.
Thank you very much, Ramanan. That was a fantastic overview about how everything is joined up in the One Health concept. And we will have time for questions. But of course, Chairman's privilege, I get to start. One of the things that you addressed was the intensive use of antibiotics in food animal production. But let me draw you out a little bit about drug classes, because one of the big drug usage classes are the ionophores, which have no role in human medicine. Do we know whether they actually pose a threat or are they benign, their use in animals?
So, John, you know better than I do that this is an ongoing debate, and ionophore use has gone up, in fact, in response to the reductions or restrictions on the use of the other antibiotics. There are those who believe that it probably contributes in ways that we don't fully understand. There are others that don't. But I'll tell you that in the farms which I have visited, which don't use any antibiotics, don't use ionophores, they manage to do this through a combination of very good biosafety and biosecurity and use of vaccines. And in fact, it's also a cost issue. If you can remove the antibiotics, remove ionophores from animal feed, you also save a lot of money. And the farms that are now starting to do this that I'm aware of are the ones that have the ability to keep everything else, all infections in check, viral, bacterial. And when they're able to do that, then they really don't need any other control measures at all. So my question back to you would be, are there measures that we can put in place that we don't even need the ionophores?
Yeah, look, I mean, and that is a very good question, Beck, and I think the whole world has been debating this issue. One of the questions I'll then throw back to you, we can have a discussion here, is do we ever envisage a time where antibiotics will basically be totally unnecessary in food animal production, or will we need some antibiotics to maintain animal health and get clean food?
Well, I think the use of antibiotics for treatment is reasonable and okay. It's the use for metaphylaxis or for growth promotion that is really the part that one would question. And of course, all the experiences across different countries show that when we reduce the use for growth promotion, the use for treatment does go up, but it doesn't fully offset the amount of reduction that you see in growth promotion. So you saw that in Denmark, you see that in the United States, that there's an offsetting increase in treatment. But that increase is much, much smaller than what you're saving by not using it for growth promotion. And I certainly think so. I think, interestingly, I remember talking to folks in the industry about whether developing countries, like India, like Indonesia, could reasonably phase out antibiotics for growth promotion. And what the people who are really experts in raising animals in this way, what they say is that the new production systems that are going into place in most LMICs are modern state-of-the-art equipment. They're not, there's not backyard farming that's accounting for this huge increase in poultry production in India. It's really massive factory farms. But when they do that, they have the biosafety, biosecurity abilities in place already, and it only takes an additional nudge to get antibiotics out of those production systems. And I've spoken to many small producers, even in India and in Sri Lanka and other places, who don't really want to use antibiotics. They're aware it's a problem, the fact that it's a problem. They're aware of the fact that they are on the frontline risk for the problem because they're the first to get infected. But their question is, tell me how to do it and I will do it. So I think it's a responsibility for us to really work with the animal industry to get antibiotics out of growth promotion. And that opportunity is there and the imperative is there. So I think the time is really now.
Yeah, that's great. I'm having fun here, so if anybody wants to ask a question, please feel free. There are microphones in the aisle. One of the things you really hinted at there is in terms of reducing or minimising antimicrobial use in food animal production, or humans for that matter, is it up to, if you like, the individual farmer, or is it up to governments to regulate? And that's a debate I certainly raged in this country in Australia, but what are your thoughts about that?
That's an interesting question, and I think it really is very country dependent. I think in Europe it happened originally in Sweden, and not driven by government regulation, but really driven by a news article showing the amount of antibiotics that were being used in animals. And people then responded by saying, I don't want antibiotics in the meat that I'm eating. It had nothing to do with AMR at all. It had to simply do with this idea of people not wanting antibiotics in their food, which then resulted in the government regulations, and then that then resulted in much of Europe removing medically important antibiotics from growth promotion. In the United States, it was virtually impossible to have that conversation prior to when consumers decided that they didn't want antibiotics in their meat. And of course, some government nudges can help. Very few people are aware of the fact that one of the most profound changes in the United States that resulted in antibiotic consumption in meat going down was not necessarily the FDA guidance 213, which basically discourages it, but it's still voluntary. It's a federal government notification in 2015, which basically said that if you're selling to the federal government, all things being equal, if you don't use antibiotics in your meat production, then you get a preferential ability to sell to the federal government, which is everything from the military, the cafeterias, the school lunches, everything else. And I think it's these sort of small tweaks where you change the incentives, and it has to go hand in hand with consumer preferences as well. But if we're able to do both of these, we don't need to come down with national bans on antibiotic consumption in growth promotion. Of course, I'm not objecting to the idea, but I'm just saying that that is possibly not the most effective way, because you don't bring everyone along. But you can bring everyone along when consumer minds change. And at the end of the king, and if they decide I don't want to eat that meat, then producers have to pay attention. So I think our best bet is to tell consumers, forget about AMR, just tell them that their meat is raised using antibiotics. I'm willing to bet that a lot of people really don't want to see that in this day and age.
Yeah, thank you. That's really wise words. So a slight change of tack, but on a similar kind of theme about whether it's should all happen from the grassroots. Bit odd for when you're including grazing animals, but from the grassroots, or whether it should happen through government intervention. One of the issues that we grapple with in this country, and I know every country is, so far we don't have a single organisation at the federal government level that says we are the effect or harm of One Health AMR. We have One Health committees, but they don't have any executive functions. Do you think there's ever going to be a need for countries to have this kind of central effector arm that involves Department of Health, Department of Agriculture, Department of Environment, or do you think we can just muddle on as we are, occasionally having to correct the deformities in one of those portfolios?
I mean, this is just obviously one point of view, but I think that as we realize that our biggest threats are no longer avertable simply by working in one domain. We were able to do that in the past, John, I think, because our focus was on interventions which did work within one domain. So, for instance, childhood diseases, much of the increase in life expectancy that we've seen globally over the last 100 years has come through improvements in child survival. To improve child survival, we didn't need to work in a One Health way at all. That was not needed. You just need to deliver vaccines to kids, and you could make that happen. I think we're out of that domain now. I don't think we can get a lot more purchase out of vaccines for kids. We need to think about other threats. And if you look forward, I think the biggest infectious disease threat that the world faces, without exception, is AMR. It's the one that is growing, and it's the one that will grow just because of the nature of the problem. If you look again at climate change related threats, these are all by definition things that you cannot address from one domain. So I think it is, I don't think we have a choice. I think we're going to have to think about various problems in much more of a One Health sense when we had the luxury to not do that for the last 100 years. And for that reason, the response mechanism, including, as you say, the effector arms, have to change as well to be responsive to thinking about, well, how am I going to preserve my ability to use antifungals for crops while also using them for humans? that's not something that one agency can figure out. If someone is going to say, well, how am I going to figure out how to, how to prevent emergence of AMR in aquaculture, which could have profound impacts on foodborne infections? That's again not in just one domain. So I think we'll be forced in that direction, and whether countries are leaders or followers, that remains to be seen, but we're all going to end up in that place.
Yes, okay, that's fantastic. Well, Fred, I have a question from Fred Ten over here, so thanks, Fred, for asking a question.
Thank you. Fred Tenover from California. I really enjoyed your presentation. One of the things you didn't mention was the use of antibiotics on plants. And back when I was at CDC, heading up the Office of Antimicrobial Resistance, I used to get these requests for approval of using gentamicin or streptomycin in orchards to prevent fire blight, which is an Erwinia disease. And the tonnage that they were using all across the US was relatively low, but the exposure was enormous. We're talking about literally acres and acres of trees that were crop dusted because that was the way they spread the gentamicin. And I just wondered if you see this as not really an issue because it's a small amount, or if it's something that we just haven't paid enough attention to.
So that's a great question, Fred, and thanks for that question. I try to see these in ways of looking at hazard versus risk. And, there are things which are hazards. We probably are creating resistance in some domain out there in the environment. But unless we can actually see some sort of a link back into the domains where it will make a difference. Resistant pathogens by themselves don't pose a threat to anyone. They can survive anywhere, and they can do what they want. They're obviously a threat only when they're inside a sick patient or a sick animal. And I guess the literature on where that crop dusting then comes back to humans is rather sparse. I have looked at it, but we just don't have the connects to understand them as clearly as we do, for instance, for the use of antibiotics in terrestrial animals. So I also anticipated that I might run out of time. I didn't, but I do have some slides on this. The area where I worry more about the use in animals and use in plants and humans is really for the antifungals, because it's almost it's the one class which we're using commonly, the azoles. We're using them in treatment as well as what we're using on plants. And the difference, I think, between the antibiotic use in the fruit trees and the ones with the fungals, the antifungals, is that the volume of antifungal use is much greater, number one. And number two, the alternatives are far fewer. If you have a fungal pathogen affecting your plants, you can have widespread crop failure. And in a sense, we can't deny the use of antifungals when it comes to agriculture. So I think that's the domain where I would probably worry about a little bit more for these two reasons. The single drug that we're relying on, then plus the fact that we can't really do without. I don't know if you had any thoughts there on the antifungals.
Well, I think that's actually a great point, and I'm glad you raised that. It certainly is a concern, especially when we see more fungi being disseminated through and after COVID. Thank you.
Okay, are there any other questions from the audience? I have one here. Is that David? Yeah.
Thanks very much for quite an informative talk. My question has to do with if we had to treat animals, what are your views in terms of the risk and benefit of using animal-only drugs, or could we use off-label antibiotics if we are to treat animals?
Well, hopefully thanks for that question. I think hopefully the volume of antibiotics that we can use to treat animals is not going to go up at an exponential rate. And that's why I sort of put up that slide which showed that it's a question of how many animals we have as well. When you think of overall consumption, both of these really matter. And I think the rate at which we're expanding animal protein consumption is absolutely unsustainable. The fact that most of our mammalian biomass is actually animals that people eat, 60% of it, is probably not sustainable, in the long term, given that pace of increase. So that's the first thing to worry about. The second, of course, is then what antibiotics to really deal with. And that's a slightly more complex question because there's cross-resistance, there's, it depends on, the forms in which resistance are being carried around, whether on plasmids. And I don't know if there's a straightforward answer, and I'm certainly not the expert in sort of understanding exactly how the cross-resistance is going to work. So I think this is a more complex answer, which I don't really have an answer to. Obviously, all things being equal, we'd want to keep medically important antibiotics out of the treatment for animals if we possibly can. But I think overall, we should be paying attention to the bigger picture, which is, can we reduce the number of animals that we have to give any antibiotics to? And that might be the first step before we got into, also the question of which antibiotics we're giving to animals, which I certainly agree that we need to be thoughtful about what we're doing there.
Okay, look, if there are no more questions, I'd like you to thank Ramanan for a fantastic talk, showing us a really true global perspective, global across all these different environments and animal groups. And I hope that you've all learned as much as I did this morning. Thanks very much, Ramanan, it was great.